Okay, so today I'm going to discuss about two topics. One is dynamic host control protocol, which is DHCP, and the other one is network file system. So these are a few topics that we have on the networking side. So I'm starting one after another, and we'll see. So okay, we'll start with DHCP. I have this agenda introduction to DHCP. We'll see how the DHCP would work and what are the configurations that we need to make for the server and the client. Then I have a quick demo to show since I have two nodes. And other than that, we have another topic just called NFS. We're going to see how it works and the configuration and the demo. So these are the things that I have for today's class. Coming to DHCP, DHCP is a network protocol that is used to get the IP addresses automatically instead of manual configuration by the users. So this DHCP server should be residing or would be hosted in the network, and all the systems which are connected to in the network will be able to receive the addresses offered by the DHCP server. So this will work within the network. So this is one thing that we need to keep a note. And this DHCP protocol is not only meant for computers, it can also be used for any nodes, including smartphones, printers, and anything. So it's not only for laptops. So whatever things that we have, we can make use of the DHCP. We have a TCP IP stack running on it, then we should be able to get the DHCP server offering IP addresses to those devices. So this is a client server model and works on port number 67 for the server, port number 68, UDP port number 68 for the client. So I have, you can see the picture here. So there are three systems, one acting as a DHCP server, and there's a range of pool of IP addresses configured in the server. And these clients connected to the network actually sending out a request to this server asking for assigning an IP address, and the server assigns them an IP address from the address pool that he has. So after which these clients would be able to communicate to other things, other machines. So when you see DHCP functionality, so initially the moment if you switch on the system and or if you switch on the interface where you have the dynamic interface configured. So what I mean is when we configure the network interface, we can configure it as manual interface or a dynamic or an automatic interface. In case if we have configured a network interface or a network port as a automatic port, so the moment we bring that up, so it will start a DHCP discover message to the it will be a broadcasted message and it will be sent to all the people within the network, and the server who is receiving this discover will be able to offer an IP address to the client who sent this offer discover message, and finally he will be able to get the IP address. Once he gets the IP address, he will further send the DHCP request to get some more network related informations like ARP related information, things like that, which might be required. And also, this client needs to make sure that there are no other nodes which are having the same IP address. So this DHCP request has been sent by this client to the server again. Server says there's nothing, nobody else is there, and he gives an acknowledgement, and finally he'll be the client would be able to connect to the network, and he will be able to talk to other clients. So this is the basic functionality of the DHCP server. So coming to the configuration parameters, uh, so there are multiple things that are there. I have picked up only two, which are very important ones. Subnet declaration is one, and the other one is the lease time. So these are the two things which we may have to be aware of. Without this, the DHCP server would not be able to function properly. So this subnet declaration is directive, which is there in the DHCP file, which is a configuration file which is present in the etc directory. And we may have to make a subnet declaration, which means this server can offer IP addresses for different subnets. So for all of these subnets, um, we may have to give a specific configuration that includes the range of IP addresses. Other than that, other range of IP address that can be offered for that subnet. Apart from that, we have options to give the router IP address, subnet mask, domain search, domain name servers, and time offset options, like which standard time should be assigned to the specific client and things like that. All of that can be configured as part of the DHCP server configurations, a subnet declaration. So I'll show this configuration in a moment. The next one is the lease time. So there are two parameters that are there as part of the lease time. One is the default lease time. The next one is the max lease time. Default lease time would be taken up in case if we do not have a specific time allocated for a particular client. So the default lease time typically would start by 300 seconds or so, and maximum it will go up to, I mean, one day, I believe 8,600, 86400. So that many seconds. Yeah, that means one day can go. So every day, this just before the release time is basically is the time for which the IP address offered by the server would be loaned for. So when the IP address is about to expire, so the client would send out a renewal message to the server, and the server would get this renewal message, and he would renew the lease again. So this is a job that happens in the background, and we don't need to bother about. Yeah. And once the lease time expires, and there's no message from the client, so this server would give a notification to check whether the client is still alive or it is switched off or something like that. Based on that, they can remove the IP address and hence that can be offered to the other clients. So the IP addresses that are configured in the server would be used on a rotational basis. So you suppose if the client is gone, and it's not, the IP address that is offered is not in use for more than the lease time, so the same IP address would be offered to the next client who is requesting for the IP address. Okay, so let's see the uh, configuration steps. So first we have to install the DHCP server for CentOS and Fedora. We have to say DHCP-server. This will install the server for us. And this is the subnet declaration we may have to make. So this is this is a subnet declaration that we have to make. In the This file is present in the dhcpd.conf under etc DHCP directory. So this subnet declaration is I have taken one subnet because I have just got two nodes. So just one subnet is what I have assigned. So this subnet is in 192.168.50.0. Net mask is 255.255.0, and range goes from 192.168.50.50. Starting address and the end address is going to be 100. So this is a class C network, and hence it can hold up to 255. Starting 255 clients, it can manage, or I can assign IP address. So likewise, we can go for class A. Class A means we will have more number of clients. Class B, again, the set of clients. Class C will be just 255. So this default lease time and max lease time is I have given this over here. So in case if I do not give this, so this default lease time and max lease time would be at the top of this configuration file, which will be utilized as a global parameter for all the subnet declaration. So even after that, so in case if we want to override that global configuration file with the global configuration parameter with a specific configuration for the clients or for the network that we are intending for, we can specify our own lease times here. So that's a second step, and third step is starting the server, enabling the server, and uh, yeah, so that's about the thing, and we can uh, at this uh, on the client side, we may have to bring up uh, the client, and we should be having an IP address or a network interface which is connected to this network. So we may have to make sure that that port is connected to this DHCP server's network. So we need to make sure. So that's what I have mentioned it here in the point number 3. And that's I have done it in virtual machine, so it's a little different. So I'm going to explain that how to do it in the virtual machine. And once it is done, so we can bring up the interface that is configured for automatic IP address configuration. Once we bring up that interface, it will send out a DHCP uh, discover, and hence you will get the IP address from the server, and which we can see this message from the log, which is present under the /var/log/messages. So under this place, we'll be able to see the messages that are sent from the server, received from the client, and things like that. And to see the lease database, there's a file called dhcpd.leases, which is present under var lib dhcpd directory. We may have to go there and check how long this IP address is leased for, and we can check for internal verification. So this is what the DHCP server is all about. So I'll show the demonstration now. So I have got two nodes, node 1 and node 2, node 1 acting as a server. And to install the DHCP server, I may need to give yum install -y dhcp-server. This will install the DHCP server for me, and it is already installed. So I have nothing to be done explicitly from my side for me actually. Okay, so that's the first step, and the next step is to configure the DHCP configuration. So that's a configuration that we just looked at now. This configuration is present under /etc/dhcp/dhcpd.conf. This is a configuration file. So in my mostly, if you have a fresh CentOS installation, this file might be empty. I have created this file based on example file. The example file is present under here. So there's an example file, example configuration file that is present under this directory user share doc dhcp serve conf example. So from this file, I created this file after taking a quick backup. Okay, so this is a configuration file. I made some comments, and I did not make much changes here. There are some default configuration in case if you are using any of these networks 10 to 152, 10 to 52, it's 10 to 54 and things like that, but better to comment. So it's better to comment all of these in case if you do not, I mean, in case if you have some things, it might give an issue here, or it might contradict. So I have given my configuration over here, the last line. So I did not disturb anything. So if any of this configuration doesn't matter or doesn't make sense to you, you can remove them. So in here, I have given my configuration. This is my configuration 192.160.50.0 and ranging from 50 to 50.100. So this is the range of IP addresses that I have in mind for all my clients. And there's one more configuration that I want to highlight here. In case if you want to, for example, if you have a web server and things like that, this web server's IP cannot be.
Oh,
Shafi, did you say something? Because I'm not able to hear you properly.
Alex, you can continue. You can continue. We just received a phone.
Okay, okay. Okay, so in case if we have to fix an IP address for systems like a web server where we cannot afford to have different IP addresses on different times, we may have to fix an IP address. So we can do that for DHCP as well. So this will not have any uh, um, this will be fixed, and this will be tied up with a hardware MAC address. So if the request comes from, if the a client having this MAC address is mentioned here, 0800, this MAC address. So then we can either give the fixed IP address here. So fixed address is given a domain name. Instead of that, we can give the fixed IP address. So if the DSP discover or a request message comes to the server with this hardware MAC address, so the IP address would be offered by the DHCP server as mentioned in this location. By this way, we will not have this IP address used by anybody else, and it is completely reserved for this purpose. DHCP configuration is done. Release time is done. So I've started the DHCP server. Just show the DHCP server is running. And if you see my network ports, ENP0S8. So this is one of the interface, one of the network interface. And I want to run the DHCP server on this interface. So looking at this configuration file, so the DHCP server will come to know there is an interface which he may have to use because that is lying in this network. So this network is 192.168.50.1, and he'll get to know this is the IP address upon which this DHCP server should be bound to, and so he will use this IP address for the DHCP server. And if you see here, uh, this is my client side. We don't need to do anything else but to create an interface um, in P0S8. It has already obtained the IP address as 50.50. That's the starting address, and I'll just do a quick shut down or deactivate this interface to show. NMTUI is a utility which we can use to bring up an interface, configure an interface, and things like that. So I'm using this NMTUI. This is a very handy tool that we can use instead of using NMCLI, which is a little complicated because the CLI commands are very big, and instead this UI thing would be handy. So I've just deactivated or brought this interface down, and I'm going to exit. And if you see here, ENP0S8, previously it was holding this IP address. Now there's no IP address here. It is empty and it is dynamic. I mean, we can see the connection DHCP client to the interface. And if you see here, I have configured this IP address as automatic. It's automatic, which means it's enabled to get the IP address from the DHCP server and not manual. So now we can activate this by I have activated this, and if you see here, it has got the IP address from the server 192.168.50.50 by sending a DHCP request and getting an acknowledgement. So let's see how whether it is happened truly or not. We can see that by giving var lib messages, and this will be a very long message instead of that. So to see the last 10 lines, we can give tell -10. Var log messages. It's not var lib messages, var log messages. So you see here, so it has sent this DHCP request message just now. You can see the state. Just now it has sent this message and it has received the acknowledgement from the server. So it has received the DHCP request from the client and it has given the acknowledgement that he can continue to use this. Okay, I told you that there's a lease database that you can take a look. So if you see the lease database, var lib, so multiple time it is requested before expiry, and hence we see this lease database being updated again and again. Okay, so that's about the DHCP server. Any questions? If you have, you can let me know. Otherwise, can move on. Any questions, Safi, Santil?
You can continue.
Okay.
Yes.
Okay, so next topic that we are going to see is network file system. Um, network file system is also a file system, but this file system is a little different in the way because it is the file system is distributed in the network. So there's a distributed file system protocol that's being used for this purpose. So when you say distributed file system, so which means the file or a directory will be shared in one server, and this server location or the storage location can be made available to all the clients connected to the network, and all of these clients can mount it into their own file system as if it is like their own storage area. And it also uses NFS server and a client model. So the latest version of NFS is 4.1. So that's the latest version, 2010 released. The usages, when you say it helps us to easily share any data among the clients. Centralized administration can be done on the NFS server. Who all can access to the directory? Who should not? Who should be denied access? And who should be given read access, write access, and many other configurations we can give. So it gives a centralized administration, and it gives additional security in case while we are working with different systems over the network. So it'll provide the required security to secure the data. So how will NFS work? So there are disk space in the sense physical disk space, which is available in the server side. So the server is located at the right hand side, and the blue circle that we see has the disks, which means additional disks which are available in this. And these disks which are available can be made visible to these NFS server, NFS server, and this NFS server takes care of making this additional storage available to the clients that are connected in the same network. So once this space is visible to the people in the network, so and if they have the permissions and rights, they should be able to mount the storage space or the directory onto their local system. So that's how the NFS would work, and the whole thing happens on the network layer. And without having the network, so this NFS will not be a possible thing at all. So both these clients or both these machines should be reachable, and there should not be any interruption in the uh, connectivity. Okay, so NFS server-side configurations. We need to install NFS utils, and NFS utils has the list of utilities required for the NFS server to run. So we have the NFS server installed, so we may have to bring that up or start it by giving the command start NFS server or PC bind, and enable both of them. And once it is done, so NFS server will be up and running, and we can create a shared directory. I've created a shared directory by name NFS-share, and I kept this directory under the I kept this directory under the root. And next thing is actually we need to give the access rights so that anybody can uh, access it and read and write this directory as well as the files that are stored inside this. And third item is the configuration that we have to do in the NFS server. This is about the directory configuration, or how this is the main configuration that is required for the NFS server. And this configuration is like this. The name of the configuration file is nfs-share or underscore share. That's the name I gave. And star, which means star is actually the star actually means the default thing. So which means anybody can access the uh, storage space that is now being talked about. So that is the NFS underscore share. So in case if you want to restrict it to few IP address, yes, we can do so. That case, we may have to give the list the IP address that we wanted to give. So in the next example, I given the IP address explicitly 192.168.100.187, things like that. So you can also give such things so that you can restrict the NFS access only to the machines. So there are options here: read, write, sync, no root squash. Read, write means read and write permission should be given. What kind of permission should be given, whether read or write or both? So that we have to give RW. Sync is basically if a client makes a changes, it has to be immediately synced to the actual hard disk. So that we have to make. So we have to give a configuration for sync. And no root squash is a configuration that's required whenever if a client creates a file, so it will be created with a user nobody. So to make sure that there is no a question about the ownership and things like that, so this is being followed. And suppose if it is in the root, so all of these root permissions would be available for the client as well. So that's the reason for having this no root squash. Once we configure the shared directory, so we'll have to export it. Uh, the this configuration is present in a file called export s, which is present in etc. This is the location that we have to make this configuration. Once we make this configuration, we have to give export fs -a, which will make the files and directories uh, exported to the kernel. So kernel will get to know about the file and directory when we give export fs -a. And after now we can give the restart the NFS utils and or PC bind. So these are the two things that we may have to enable and restart. And the last thing is the firewall. So we may have to open up the firewall port for NFS and make it permanent. So that's a configuration that we have to do at the server side. And coming to the client side, same thing, we may have to install NFS utils first and restart the NFS utils and enable them. Firewall needs to be enabled. Afterwards, the mounting can be done directly. The next important configuration that we have to make is in export yes. So this configuration, see the configuration. Export S file. So only this NFS hyphen underscore share. That's a directory that I have created in the server for sharing within the network. So this directories need to be mentioned. And the next parameter is the IP address. I have given the IP address 50.50. So this is my client's IP address. So if you see here, this is my IP address. So I've given this IP address. I've given RW sync and no roots cache. NFS is enabled in the client, and the in the server also it is enabled. NFS is enabled now in the firewall. So that is one. And coming to the client side, we may have to install the NFS utils and then bring that up. So we have to start that and enable it so it comes by default whenever we reboot the system. Enable the firewall port to allow NFS even in the client, and then we can start straight away directly mount the share directory. So I have created a destination point slash mnt slash NFS. It's my destination point. Currently it is mounted already, so I can unmount it giving 192.168.1 m NFS share. So it's unmounted. There's nothing here now. Let me mount it now. So 192.168.50.1. So that's the NFS server's IP address. And now I'm giving NFS underscore share. So that is the uh, common directory or the share directory, and I'm going to mount it under this location. Mount NFS is the location mounting, and it's successfully mounted. And I can see this. When you give df minus t, you can see this. And we can go to NFS directory and we can create a file, NFS functionality. Okay, so this file is here, and if you see here, so this is my server, and if you see NFS, and the file is present even in the server as well. And let's read this content, and the content is here. So by this way, we don't need to have a storage that needs to be there within the local system. Instead, I can have my storage in the network, in some other PC, maybe a old one where we do not want to uh, throw it off, but we have a good storage there, so we can connect it to the network, and then we can use the NFS to make use of the storage which is available in the server or a system. So this is how the NFS would work. So yeah, pretty much that's all I have. We have covered DHCP server client and the NFS server client.